All right, guys, in this video, we're going to be looking at graphing logarithmic functions. Now, there's a couple things I want to remind you of. One is that a logarithmic function is an inverse of the exponential function, okay? So the function that was y equals ab to the x, and now our function y equals log base b of x, these two here, these two are inverse functions. They're inverses, okay? Now, we learned last week what exponential functions look like, okay? And we learned that they either, here's my x and y coordinate plane, they came down like this and got really, really close to the x-axis like this, or they came up maybe from the bottom and got really close to the x-axis that way. But we learned that this x-axis was an asymptote. That was a line that the graph, as it approached infinity, got closer and closer to, but it never touched it, okay? So remember what an exponential function looked like, and then remember that these two, an exponential function and a logarithm, are inverse functions. All right, so I'm going to graph a couple, and then I'm going to let you try one and see how you do. All right, y equals log base 7 of x plus 2. Now, the first thing I want to talk to you about are transformations. So let's do log base b, and I'm going to put x minus h plus k. That minus h plus k should be getting to where it's pretty familiar to you by now, okay? Now, what I want you to remember is that this h right here, this number, moves it left or right, moves it left or right, and your k, this number right here that's going to be out on the end, that k moves it up or down, okay? So the k moves it up and down, and the h moves it left and right. Now, the way we're going to graph these is by going to Desmos, just like we did the exponential functions, okay? So let's look first at this log base 7 of x, and then notice it's got a plus 2 out on the end. Now, that plus 2 is not inside of parentheses, so it's out on the end. So my transformation is going to be that this is moved up 2. So I'm going to go ahead and write that in. This is moved up 2. Now I'm going to go to Desmos and actually graph this, okay? And I'm going to show you how to do that. So you're going to go to the Desmos graphing calculator, and then we're going to key in f of x equals, now, this is where you've got to get your log function. So you're going to come down here to this keypad, click on it, then you're going to come over here and click on functions. Then it's probably on trig, would be my guess, when you click on that. And then you're going to click on miscellaneous, M-I-S-C, and then you're going to click on log base A. We're not going to use this log because this is the common log. This is the log base 10. We have log base 7 in this problem, so we want log base A. Now, if you'll notice, I can put my 7 in. And then I can arrow over to my parenthesis and put in x, but then I'm going to go outside that parenthesis to put the plus 2. All right. Now, you can see that we have a graph. I'm going to minimize that keypad. You can see we have a graph that does this. So this graph, it's coming, if we read it from left to right, it's increasing, right? It's going this way. So it's going up, 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 up forever. But notice, now remember, when we had exponential functions, our asymptote was the x-axis. So now that this is an inverse, it's like we're flipping this. So no longer are our asymptotes going to be horizontal, but they're now going to be vertical. And in this case, our asymptote is the line x equals 0 because it approaches the y-axis. You can see that. Okay, it almost looks like it touches it, but really it doesn't. So our asymptote here is the line x equals 0. So I'm going to go back over here and fill that out. Our asymptote is x equals 0. Okay, now let's not worry about the other stuff yet. Let's see if we can get some points to put on this graph. Okay, we just need a couple of points to label our graph. So this is where we're going to do that f of, let's see, and I want to get an integer. So if I put in -1, that's undefined, all right? Of course it is, because that's over on the left. If I put in 0, that's also undefined because it never touches 0. All right, so let's put in 1. Okay, f of 1 equals 2, you can see there. So I'm going to come back over here, And at 1, I'm going to plot the point 2. Okay, let's get one more point. So we're going to have to get something out here. Let's try 2 and see if that's an integer. Nope. What about 3? Nope. 5? 6, 4. That didn't work. Okay, let's go to 6. That's not. 7? There we go. F of 7, we get 3. So I'm going to come over here. And at 7, I'm going to go up to 3. All right, now at this point, I have enough to know that this graph comes like this and does something like this. And it's going to get closer and closer to that asymptote. And I'll draw in your asymptote for you. We did this last week, so you can see. This has a vertical asymptote right there. Okay, so it's getting closer and closer to the line x equals 0, but it's never going to touch it. Now, for domain are all your x values. Now you can see on the x, I don't go past this 0 here, but I go all the way out and it keeps going to infinity. So my domain is going to be 0 to infinity. And if you'll remember when we did exponential functions, our range was always either negative infinity up to 0, or it was 0 up to infinity. Okay, so these have switched. It's inverted like we talked about. All right, the range, that's all your y values. Now, our y values, they continue down forever, and they continue up forever because this just keeps going and going and going and going. So my range is negative infinity to positive infinity. Now, if you'll remember, when we did the domain of exponential functions, it was always negative infinity to positive infinity. So again, that is inverted. Now your range is the negative infinity to positive infinity. Okay, now let's talk about end behavior. So we've got to talk about what happens to the end of this graph as x approaches positive infinity and as x approaches negative infinity. So as x approaches positive infinity, what does our y do? What does y approach? And we just use those arrows to indicate the word approach. So as x approaches infinity, so as x goes this way, what does y do? Well, y also approaches infinity. We call that end behavior. Now we have to consider as x approaches not negative infinity, but as it approaches this asymptote of 0. So as x approaches 0, y is going to approach negative infinity because it continues to go down, down, down forever. Y is going to approach negative infinity. Okay? Let's look at another graph. Now this time I'm going to start off by actually graphing this in Desmos. So let's go to Desmos and we're going to graph log base 7 of x minus 2. All right. So I'm just going to do this. Log base 7 of x minus 2. And I'm going to take that f of 7 out right now. All right. So we now have a graph that looks like this. Now this time you can tell that your vertical asymptote is going to be at x equals 2 because that's the line we're getting closer and closer to here. So now this time my asymptote is at x equals 2 because it's closer and closer to that line, but it doesn't move. I mean, it doesn't touch it. Now, x minus 2 here, this minus 2, let's go back up here, that's inside the parentheses. So that means it moves it left or right, okay? If it's minus, it moves it right. If it's plus, it moves it left, okay, inside of there. So inside of here, I have a minus, so that means this is going to be going right 2 is my transformation. All right, let's go over here and see if we can get some points to graph. All right, let's try f of, since I know I have to go past 2, let's try 3. All right, at 3, I get 0. Okay, so I'm going to come over here, and I'm going to put 3, 0. That's this point. And while I'm here, I'm going to go ahead and draw in that asymptote. That's at x equals 2. So I know I'm approaching that line, but I'm not going to touch it. Okay? Let's see if we can get another point. Let's try f of 9. I'm just going to guess here. F of 9 is 1. It looked like it roughly might be. So I'm going to go back over here to my graph, and I'm going to do f of 9. We get 1. All right, so we know this graph does like that, and it comes down like this and gets closer and closer to that asymptote but never touches it. Okay, let's talk about our domain. The domain of this function, that's all your x's. So I don't have anything that goes past 2 right here, but I have everything that goes up to infinity. So my domain is going to be 2 to infinity. My range, that's up and down, so that's everything. That's your negative infinity to positive infinity. And remember we talked about this used to be the domain of an exponential function, so now it's the range of a logarithmic function. Okay, end behavior. What happens as x approaches infinity? Well, as x approaches infinity, y also approaches infinity because it keeps going. Now we have to consider the other way. As x approaches this asymptote of 2, y approaches negative infinity. So that's our end behavior of that graph. Okay, I would like for you to pause the video and work number 3, and then come back and I'll work it and we'll see how you did. Okay, so let's go and let's graph log base 7 of x plus 2 minus 6 on Desmos. Okay, log base 7 of x plus 2, and then we've got minus 6. I'm going to take that 9 out there for right now. Okay, I'm going to have to move my graph up to see it here. All right, this time it appears that our asymptote is at negative 2. I'm going to zoom out a little bit so you all can see that. Okay, here's our negative 2. So it appears that that's our asymptote. Let's see what kind of points I can get. I think I did the point negative 1, which is negative 6. So I'm going to go ahead and graph that on mine. So negative 1, negative 6. And the other point that I chose to do was 5, I think. Let's see if that's right. Yeah. So at 5, we get negative 5. So I graphed 1, negative 6, and then at 5, we get negative 5. 1, 2, 3, 4, 5. Okay? So we have and we said that our asymptote was at x equals negative 2 by the graph. So our asymptote is x equals negative 2. That's down through here. All right, so our graph comes down like this, and it gets closer and closer to that, and it goes this way, like that. Okay, the transformations. Since this is a plus 2, that means we move it left 2. Since this is a minus 6, that means it went down 6. Okay, our domain, it doesn't go past negative 2 in the negative direction, so negative 2 is a bound, but it goes up to infinity on x. Your range, it has all of the y values, so that's negative infinity to positive infinity. And your end behavior. So first we have to consider as x approaches infinity. What does y do? Well, as x approaches infinity, y also approaches infinity. It keeps going and going and going. Then we have to consider as x approaches that asymptote, negative 2, that y approaches negative infinity. All right, guys, as always, if you have questions, let me know.